My name is Gabriel, and I'm senior Android developer and Android research and development leader at NetGuru. And today I want to talk about different approaches in designing mobile applications. As you may notice that probably I will be doing a lot of talk about offline first, and you are right. But first time, let me ask you the question. Does it sound familiar to you? Have you ever tried to get to your phone, scroll your application, for example, Facebook, Twitter, Instagram, LinkedIn, or so on? Yeah, of course, everybody is doing that. But let me ask you the question. Have you ever been in a situation that sometimes your connection has been interrupted and you have lost something very, very important to you? Because for me, yeah, it's happened several times. I will tell you a short story and the basically origin story of this talk. A few months ago, I was in a hurry to the meeting that was taking place in my office. So I stepped into my elevator. I just took my phone out of my pocket and just sent text to my friend. I clicked send icon, put phone to my pocket and ran to the meeting. 1 hour later, I noticed that I have some notification in my phone. I just checked it and it says, oh no, sorry, your message couldn't be sent to your friend. And I was like, what, why? Why my phone wasn't able to try to resend the message? Why I have to remember about it? And you know what? That's because this application was built in online first approach. That means that is a standard approach for building our applications. Everybody is doing that. It's mostly highly coupled between your API, your internet connection, and your application. Data are downloading directly from the API, rarely cached, and only databases, for example, used only for crucial data like saving API tokens or user tokens, user email, etc. I'm not saying it's a bad approach because many of applications should be architected in this way. So let me show you how it will look like. For example, that's the standard and typical case of online first approach application. We have basically two main components here, our application and our API or web server. And as you may see, these little arrows means that the communication is bidirectional. So in perfect scenario, it works like a charm. Application just ask API about the data. We are receiving the data, and application shows the content to the user. And it's all of this. We all need that, and it works great, right? But imagine a small outrage of our API. So basically, we don't have this component here. Our application is like standalone component, and application requests about data. So hey backend, give me data, because this element is actually not here. We don't have any response, any callback, and as you can see, our data flow is broken because we don't have this second line, the second arrow that indicates that the data comes back to our application. We are losing the data that our view relies on. So basically, most of application will display here some error message in the worst case. In the best case, you will have a message and a button, for example, for retry or something. But most of the application will present to you, oh, unexpected error occurred, try again later, you know, this kind of stuff. This scenario where no data can be retrieved from API can lead easily to the next scenario in which our application is dead too. And that's something that we should prevent in the ideal world, but it's really hard to maintain when your application is built in online first. So to sum up, online first approach is like standard approach for designing and building our mobile applications where uploading and downloading data is done directly by connection to the API. There is no, or is very rarely used, caching mechanism. So basically, we don't cache any data. If if so, only the crucial one. Fetching the data from the backend is mostly done on demand, so only when user is entering to the view or user has taken some certain action in our application. And I mentioned that before, but local storage is mostly used to save only most crucial data. That means authorization token, user email, username, for example, etc. And I want to be again clear, it doesn't mean that it's wrong approach and you should like stop doing it right now, because it's not true. Many of application, and I mean the like real-time focused, like stock markets, currency exchanges, etc., are ideal candidates for online first approach. Because we don't want to present an outdated data for your user. Because imagine a scenario in which in currency exchange app you will buy some currency for the old price or for the new price. It's really hard from business perspective to manage who should refund this money, for example. So we need to rethink if we need to do it on online first approach, but in the most cases, we probably should proceed and consider the offline first approach. So basically the topic of my presentation. In this case, in this approach, we will try to manage our data in the way that will allow us to make our data flow more error-proof and more predictable. This is diagram of the offline first approach application, and as you may see, it's really similar to the one I showed you before, with one small difference. We have database in the middle. It's a middleman between our API and our application. And you probably have one question. Will I have to write more code? Yeah, of course you will have. You will have to handle many cases. You will have to manage multiple database transactions and handling all the stuff that's going on between application and database. Is it worth it? Definitely. And as I mentioned, database is the most crucial part of offline first approach, but making it a single source of truth is the most important thing to do. What does it mean that something is our single source of truth? That basically means that database should be the only place in our application from where you are retrieving data or to where you are putting your data. It allows us to retrieve data before or even after our application will be closed or restarted. So we have very pretty persistent state management for free if we are using the database. And last but not least, database is much faster than a network connection. We can reduce our progress bars and time needed to display the data for the users, because basically fetching data from database is much faster than waiting for API response. So okay, let's assume that we implemented our database. For example, we can use Room on Android. Or any other implementation. It should be like plugin system, because you will probably need to test what fits the best for your app. So let's assume we have our database. We are saving and retrieving the data from the database. We don't have progress bars now, and that's really cool. But what do we don't have also? The data. Our database is empty, basically. So we need to think about the second mechanism of offline first applications, and that's data fetching. Basically, that I could replace the text and say the data downloading, but it's not the same thing, basically. But I will mention it a bit later. Basically, everything we are downloading from our network, we should save into our database. We can do this an old way, an online first approach way, so fetching the data on demand. For example, users opens the user or book view or something, and we are downloading the data forcing the user to wait a second or that data be updated. We can also hide the process of fetching data, for example, behind a splash screen. So on the first launch of our application, we can display a pretty splash screen for the user and download in the background the application, download in the background all the data that needs to be shown when the user first opens the app. And then we can, for example, connect it with the periodically data fetching. So that means every 5, 15 or 30 minutes or whatever fits you, downloading the data from the internet. We can save a lot of time and data doing it in a combined way. So for example, small parts of data can be downloaded on demand. Large parts of data, for example, can be downloaded on the independently of user activity. That gives us a pretty neat feature. That means we are controlling the data downloaded from the API. So if we have all this data saved to the database, and as you might think that there is happening a lot of downloading processes. As I mentioned, for example, something we are downloading every 15 minutes, something we are downloading on every button click. Our database will be pretty messy right now if we will start putting everything we downloaded from the API. But there is, of course, a solution for that, and that's a data synchronization. And I will be honest with you, that's probably the most hardest thing to implement in your application. Because imagine the situation that we have a big application with a lot of requests going on. For example, user can update something, can leave a comment, can download the newest pictures and chat with her friend, for example, on the communicator. How to synchronize all the things, all these things when connection will be interrupted? It's really hard to maintain. So it's the hardest topic. It's the hardest thing to implement, and you will probably have a lot of questions to yourself how to manage that. So for now, let's assume that our application is pretty easy, and we are downloading data basically from the one endpoint, and uploading only one kind of data, let's say user comments. Okay. So how we will manage the situation in which user leaves the comment, clicks tab, and the request fails. Basically, we should use our previous mechanism. That means database as single source of truth. Firstly, we should leave our comment into the save our comment into the database. Then try to update this comment on the API. If request fails, we can easily mark this comment as temporarily or is pending in database, etc. And again, or one of the previous mechanisms, that means data fetching, should upload all this pending data right away to our web service. And after putting this temporary data to the API, with every API response, we should appropriately delete those entities or update them. That's the easiest case to handle this whole data synchronization, but the main goal is to have data integrity between your database and API database. In the ideal and the perfect scenario is that user without internet connection has the same data displayed in the application as he would have when internet is completely fine. And again, after this, you might raise a question. Okay, so we are synchronizing data. That's a lot of operations. We are updating it. We are downloading it. What about our resources? We are making so huge amount of API calls and internal operations that our app might start to look a bit sloppy, right? And probably you're right. And I have an answer for that. That means caching, sorry. To connect all these pieces together, and take care of our resources like memory usage, CPU usage, because we are doing several things on the database, and also network bandwidth, we should think about cache mechanism. It's also good thing to consider, mostly in bigger apps, because those small ones have like too little API calls, and it's fine that we are doing, for example, additional 2 calls every like half an hour or so. But if there is really many things going on, you should rethink it. There are 2 ways to do cache mechanism, and ideally you will have both of them in your application. But the real world scenario is that probably your backend developer will say, no, I won't do that, because yes, you will have to implement something on your server side. And let me show you a quick example. We can implement, for example, local cache. That means we will be responsible for implementing the caching mechanism. What does it mean? Basically, the data that was accessed, for example, 5 minutes ago, should be moved to the memory. So we can have synchronous access to the data without any callbacks. And we will be able to present the data to the user right away without any waiting. So if you are fetching the data from the database, you can move them to the memory and keep it there for a while, for example. Ideally, we will have to connect it to the backend cache mechanism. So, for example, your backend developer should make some additional params to the request with last modified date, for example. So instead of calling your API in the way, oh, okay, give me a list of my friends, you should ask the backend like, okay, give me a list of the friends that actually changed since Monday 4 p.m. That will reduce the amount of data you are downloading. So for example, backend should handle it in a way that will respond with the data will respond with data that only was changed since, for example, yesterday. You won't have to update your data with the same data basically in the database. So after we have connected it together, we are fetching data synchronously because they are in memory right now. Backend implementation can reduce our network usage, so basically everyone is happy. And if we all have this kind of pieces together, let's see how our app will behave in scenario from the previous case. Let's imagine that API is not there. So once again, UI or our application is requesting data, but not from API, from DB, because it's our single source of truth. Data fetching will guarantee us that every time API is available, we are downloading necessary data and putting it to the database. So there are the newest possible versions of our data there. Thanks to the backend and local cache mechanism, we won't fetching from the API too much data, and local cache mechanism will guarantee that even if something will went wrong in this line between database and application, we still have data in memory. So we are pretty safe right there. And if user in the meantime will change something in the app, will update something, will try to upload something, and connection will be interrupted, it will again be saved in database, and then, for example, in 5 minutes, pushed away to the API if it will be available. Thanks to that, we have a pretty error-proof application. But we need to remember about a few things. The most important, database is single source of truth. Periodically data fetching is probably the best way for bigger apps. For smaller apps, the fetching data on demand should be also a good fit. Data synchronization, the worst part of this whole process, is just handling cases to ensure data integrity, and cache mechanism to ensure your application smoothness, robustness, and resource awareness. And I should probably finish it here, but there are a lot more to consider. You will have to answer many questions when you will start to architecting your application in offline first approach. For example, how often do you need to fetch the data? Is it for your application okay to refresh the data every 5 minutes, every week, every month? Maybe you don't need it at all. How you will manage the data fetching process? You want to hide it behind the splash screen, and maybe you will do it on demand. Do you need to upload content right away? If it's a message to your friend, probably yes, you should do that. But I believe that your friend can wait with notification from you that you liked his dog photo on Facebook a bit. The same, do you need to show the user that they are in the offline mode? Again, if it's a scenario like in Google Docs, when you are collaborating on one document with your friends and suddenly you can see new changes, that probably you should inform the user that he's in offline mode and that you will synchronize all the changes. Do you need to inform the user about data sync progress? Do your app need that? I will read that. How you will support manual refresh data system, like pull to refresh, retry buttons, etc., etc. There are many questions to answer, and believe me, you will have more if you will start to consider if offline first approach is a good approach for your application. And remember, it's worth to consider the offline first capabilities of your application as early as possible, but on the other hand, it is better to consider it later than not to consider ever. Thank you.
How do you protect data that is on the device when it's stolen? There are not a lot of...
Okay. Firstly, you should probably encrypt your data, database. For example, if you have SQLite, you should have it encrypted.
Where do you store the key for SQLite?
Okay, are you Android or iOS developer? So I won't help you probably with that, but on Android we have a pretty neat system for that. Key generator, we are storing the keys, it's RSA based, so it's generated with your PIN code, for example. But one thing I remember that was pretty tricky to do, that someone even communicated with the backend returned the bitmap and they was generating the keys from bitmap. But I guess that wasn't a perfect scenario, perfect case. But there are many ways. Probably RSA or some kind of other private public keys related encryption will be enough. Yeah.
How long do you want to store the offline data? For example, data is going to the connection by the month. Database should be tilted or that something?
Okay, I've got a similar question, and I will try to answer it in the way, because the question in one of the meetups was, okay, so if we want have internet connection for a while, we can have a really big database, basically, because we are downloading this data, we cannot synchronize them, so our database is growing. The easiest answer to that question is basically that data synchronization should take care also of cleaning your database. So basically, if you have seen that, last data synchronization was 2 weeks ago, and no other data was downloaded since then, maybe it's a good idea to clean up, to not make our database bigger, and to not wait infinitely to make API requests again and again. So it's the mother of data synchronization. Yeah?
Do you have any experience with introducing this offline first approach instead already existing application?
That's really good question. And to be honest, we have in one of project I will show. We have some similar architecture to this. It was meant to be an online first approach, but instead of database, we had an abstraction layer, which was accessing the API. Basically, it was wrapper on the API. Without that, it will be really, really hard to place database basically between our two major components, or app itself and API. I've done it once, but fortunately I had an abstraction layer over the API access, so it wasn't so hard. But I mentioned in the end of presentation, it's really worth to consider if you are planning to have offline capabilities of your app as soon as possible, because very often choosing the architecture indicates how it will behave in offline mode.
Okay. What is your approach for situation when two users operate on the same data, being offline, and then synchronize in different times, but updating, like the one that updated first will...
Okay. As I said, I guess I said it. If you want to have like data synchronization, it was about cache mechanism. Sorry, you will have to have a backend guy to do the job. Basically, it doesn't there is no difference between making two API calls at the same time or making them delayed by, for example, 5 minutes. So it's a backend case, to be honest. Yeah.
So what about situation when you don't want to store something in database, but you want to call API, on example payment?
Yeah, that's a really good question. Probably you can just avoid it. You can make like one shot to the API. You don't probably want to store in the database like card number because safety reasons also. I'm not saying that this connection from app to API is not possible. In this case, we can just make standard API call and on the response you can show the error. Okay. No more questions? Thank you so much.